With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
A rod of mass 4m and length L is hinged at the midpoint. A ball of mass m moving with velocity v in the plane of the rod strikes at the end at an angle 45 degree and stick to it. Angular velocity of the system after the collision. So it is given that the ball strikes at the end at an angle 45 degree and stick to it, right? So let's see the diagram first. So let's suppose this is the rod and the length of the rod is given here is L and is hinged at midpoint and the length is L and at an angle 45 degree a ball strikes and the velocity of the ball is v and the mass of the ball is m and mass of this rod is 4m. Very simple. Now when the ball will strikes, you can see it will stick to this end, right? So after sticking, the structure will be somewhat like this, and the whole system after sticking will rotate with an angular velocity omega, right? And if you see here, there is, if I take this ball and rod as a system, right, then there won't be any external force in on the system, right? So I will write the initial momentum of the two is equals to final momentum of the two, right? So initial momentum, you can see initially the rod was stationary but the ball was moving at an angle of 45 degree, right? So if this angle was 45 degree, so this was mv by root 2 and this was mv by root 2, right? And if you see, this angle is L by 2. Very simple, right? Okay, so yeah, so you can see if I take r f perpendicular into r, so this yeah, so p perpendicular into r, so it will be mv by root 2 times L by 2, the initial momentum, right? If you see, this distance is L by 2 and perpendicular component of the linear momentum is this, right? And along component won't provide any angular momentum, right? So it will be this, right? Now if you see final momentum, so the whole system is rotating, right? So if I talk about the rod is having a momentum, uh, right, moment of inertia is ml square by 12, so mass is 4m, so this will be the moment of inertia of the rod, and the moment of inertia of this ball, since it is at a distance of L by 2, so I will write m L by 2 L by 2 whole square, right? So this will be I. Now I will multiply it with omega. Simple. So now we just solve this equation and we'll get the omega. We can cancel out this m, right? So this 4 will get cancelled out by 3, right? So you will get, yeah, so you can also cancel out this L, right? So you'll get v by 2 root 2 is equals to L by 3 plus L by 4. 2 square is 4, right? Okay, so into omega. So L by 3 plus L by 4, you can see it, if you take LCM, you'll get 4 plus 3 and into omega is equals to V, yeah, into omega L is equals to V by 2 root 2. So we want this omega, so I will write omega is equals to, so this will be 7 by 12, so I will multiply 12 by 7 and L V by 2 root 2. So this will get cancelled out by 6 and further you can also write it 3 into 2, so you will get 3 root 2 by 7L into V, right? So this will be our answer. So you can see A is the correct answer, 3 root 2 by 7L into V, right? Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.